Okay, so I've been kind of tinkering around with these online tutorials, and I wanted to do a probability problem that involves three doors. Or let's actually make them suitcases. There's three suitcases, and this is kind of like Monty Hall, Let's Make a Deal. Behind one of these three suitcases is $1 million. And I'm going to give you the chance to guess which suitcase the money is behind. You can choose A, B, or C. Okay, so let's just say you chose C, or you chose B as your guess. Okay? And now I'm going to give you the chance, okay, I'm going to say you've chosen B. This is your guess. And I'm going to say that the money, I'm going to tell you that the money is not behind C. It's not in suitcase C. And I'm going to now give you the opportunity to either stay with your original guess B or move your guess to the remaining suitcase A. So the question is, are you better off staying with B, or are you better off switching your guess to A? Or does it matter? Well, this frustrates a lot of people. I've posed this to several of my engineering co-workers, and some of them get pretty upset about it when I tell them that you're actually much better off if you abandon your initial guess and move your guess over to the remaining suitcase A. Now, I do not have a great track record of explaining why this is the case, but I'm going to give it a try here, and I think I've gotten better at explaining how this problem works. So don't get upset. I know the first time it was posed to me, I thought it shouldn't make any difference at all. But the professor that posed it gave us the opportunity to leave class and come back the next day with our answer. So I worked it out, and it actually turns out that you're much better off switching your guess. So here is going to be my attempt at explaining it. Now, in the past, the way I explained it was this. Let's imagine you had 10 suitcases. 4, 5, 6, 7, 8, 9, 10. And let's just say you guessed your suitcase, and now I've taken and moved it over here. This is your guess, okay? So now, let's say I eliminate all but one of these other suitcases on the other side. So these are all, I've given you information. I say none of these suitcases here contain the $1 million. Now, to me, it seems pretty straightforward that the money is almost definitely here in the remaining suitcase. But unfortunately, I had trouble convincing people of that. So I had to come up with a mathematical rationale to explain why you're better off switching your guess. So let's go back to the original three suitcases. Okay, here's our three suitcases. We guessed this one here. Okay, now I think everybody can agree that before I give away any information as the game show contestant, we have an equal chance of guessing the right answer where the money is. And that is, it's a 1/3 chance. You have a 1 in 3 chance. Okay? Now let's think of it in terms of, this is a wall right here. Okay? This side of the wall, what's our probability of getting it right? 1/3. On this side of the wall, what's our probability of getting it right? 2/3, because each of these got a third here third here. So the probability of the money being on this side of the wall is 2/3. Okay? Another way of saying that is each one of these suitcases that we did not guess, we have an evenly distributed probability of getting it right. Each of them have an equal amount of this 2/3 to get the correct answer. Okay? So if we take 2/3 and divide it by 2, the answer is that each of those has got a 1/3 probability. But here's the thing: the game show contestant, or the game show host, has given us information that says this is not the money. Okay? So now we have that 2/3 probability on this side, the 2/3 probability that the answer, correct answer, was on this side of the wall. Here's our wall. Gets shifted entirely onto the remaining box. Okay? So now we continue to just have a 1/3 probability of having the correct answer on our original guess. Okay? But this box remaining on the other side of the wall now has 2 out of 3 chances that you're actually going to get it right. Now, another way to think about it is the only way that you are wrong when you switch your guess is if you correctly guessed where the money was on your first guess, and that was 1 in 3. You had a 1 in 3 chance of correctly guessing it. So you would lose 1 out of 3 tries if you switch your guess, but you win 2 out of 3 tries. Okay? Now, I know that's not going to convince a lot of people, because believe me, I've tried explaining this, but I hope that convinces some of you. Now, let's do that problem with if there was more than one box. So let's say there's 5 boxes. Okay? Now we guess, this is our guess. We know that we have a 1 out of 5 chance of getting it right. And on this side of the wall, we have a 4 out of 5 chance that the money is on this side of the wall here. Okay? Now, let's say we eliminate 2 boxes. So the game show host says it's not behind this box and it's not behind this box. So now our 4/5 probability is evenly distributed among the remaining 2 boxes. Okay? So let's see. Each box would be 4/5 divided by 2, 4/5 divided by 2. So each of these boxes now, 4/5 divided by 2 is equal to 2/5. So each of these boxes has a 2/5 probability of containing the money. So if you were to switch from your original guess over to either one of these other guesses of boxes, you would double your chances of winning. You would go from 1 out of 5 to 2 out of 5 chances of winning. Okay? So that's it. I hope I convinced some of you. I know I didn't convince all of you, and for those of you I didn't convince, you're frustrated with me right now. But work it out for yourself, and I'm sure that you will eventually convince yourself that if you ever go to Vegas and you face this problem, you're much better off by switching your guess. All right.